ReefDudes is sponsored by Brightwell Aquatics and Bulk Reef Supply.
Today we're going to hook up a CO2 sensor to the Apex. What's going on, guys? Devin from ReefDudes. So today we are going to do a project that's been on my Docker for quite a while now, and that is hooking up and piping in a CO2 reading into the Apex. Now, I actually saw the instructions for this posted ages ago by Thomas and Harry, and so shout out to them for this one. Give me the idea for this. So what we're going to use is a Siemens QPA 2000 CO2 sensor. So this is an industrial sensor. However, in order to get this into the Apex, we are going to be using an ASM module. Now, the ASM is the Advanced Sensor Module. It comes with the PMK of the power monitoring kit. That's the easiest way to find them. Most places don't sell this directly, so if this is something you want to do, you would have to contact Neptune directly and get it that way. Now, a couple notes on this one. This is a little more of an advanced project. You got to be comfortable cutting, soldering, stripping wires. Actually, you don't really need to solder, but it's nice to have that ability, those kind of basic skill sets. So I was digging through my box, and normally I was just going to cut the end off a BNC sensor for this. I found a video bail-in, so I don't know 100% if this is just a straight through pass-through, but I'm going to do a couple tests, because if this works, it'll be a really easy way to connect the wires to the Apex module. Now, this is expecting 0 to 5 volts, so we need to make sure that this is outputting 5 volts instead of 10 volts. There's a few different models of this, and on this guy right here, I believe there's a jumper across there. It outputs 10 volts, and without it, it does 5. Double check the instructions because it depends on the model, but we are going to test this with the multimeter before we hook it up to the Apex just to verify it's set up correctly. The other thing that we're going to need is a power source. Most industrial type sensors run off 24 volts. Now, conveniently, the Apex has that 24 volt accessory port. So you can pick up the DC 24 to bare wire cable, which we're going to use to power this. So we're going to power the sensor off of the EB832 24 volt accessory port. Okay, we got our wires pulled through and we're ready to wire it up. If we look on the bottom here, we have pins 3, 4, 5, 6, 7, 8. Pins 4 and 5, so G0 and U1, are going to be for our BNC probe. And pin 5 is going to be our positive, and pin 4 is going to be our negative. So we'll put the positive for pin 5. For G0, that is our ground. So we're actually going to put the ground from both the BNC and from the 24 volts to pin 4. Now, the only wire left is our positive from our 24 volts, which is going to power the sensor. And this guy goes to pin 3. Now, just for a quick recap before I screw this back together, we have pin 5 is your positive from your BNC. Pin 4 is your negative for both the 24 volt and the BNC, and pin 3 is your positive 24 volts in. Now, the other side of this is going to go to a BNC connector. I just did find a quick connector one actually I had laying around. Now, this is for video. I'm pretty sure it just passes straight through, but let's quickly check the impedance, which is the ohms on it. 1.1 ohms, and the negative, which is the outer ring, is getting about 1.7 ohms, so very minimal. So I'm pretty sure this is just more or less a straight through connector. So we should be good to connect this up. Now remember, before we actually hook this up to the ASM module, we're going to check it with a voltmeter and confirm it's outputting 5 volts. Very important because you don't want to damage this ASM module. Again, make sure you match up the proper leads. If this one's labeled, so we got a positive or negative. If it wasn't labeled, positive is your center pin and negative is the outside. So you can always verify with the multimeter. Not like I mentioned it, but I ended up picking up this sensor off eBay. They're a little harder to find in normal retail places. They're a little overly priced. I think it cost me about 90 bucks off eBay. So just to make sure we don't break anything, let's get this plugged in 24 volts, and we're going to double check the output voltage before we plug into the ASM module. All right, now before you hook this up to the ASM module, you want to double check your voltage and confirm you're actually running at 0 to 5 volts. So your number should be roughly between 1 and 3 volts. Right now we're at 2.619. Now, if it was higher, generally on this meter that I have, the QPA 2000, there's a jumper you can remove that'll drop it down to 5 volts. Now, something was buggery on mine that wasn't working, so I used 2 resistors in series to make a little voltage divider and drop it down. So now to figure out your actual CO2 reading, take the voltage times 400 is your formula, so 2.62 times 400. So that should be reading 1048 on the Apex, roughly. Now, in order to set this up, we got our new module in here. So we're going to go into Modules and ASM. Now in ASM, there's two things you got to do. The probe type is 0 to 5 volts and the min and maximum range. So the minimum is 0. The maximum of the sensor is 2000. Now there's a bit of a bug with it scaling, so you had to play with it a little bit to figure out what that number should be. So right now I have it about 1650. And if we go back into our sensor, I did just hit the little config and renamed it to CO2, so it makes sense. And now to know if our setting is correct, again, we measure our voltage across these two pins. 2.615 times 400, so 1046 and 1045. So we basically got it right on the money now. So this should be an accurate reading based off the voltage. And in my case, it was 1660, seemed to be the magic number. And there you go, guys. We now have CO2 reading, reporting, and tracked on our Apex. So it's going to be really cool to see how the pH correlates to the CO2 levels in the room.
All right, we've now had this running for a couple hours. When I first plugged it in, it was reading 1032. Now my meter was reading a bit lower than that. Right now it's reading about 570 and this is reading about 780. Now I looked at the manual for this online. It said plus or minus 100 points, which is a pretty darn big range. Now I did open the windows probably about an hour and a bit ago, and that's why I saw it drop from 1032 to 783. So it gives you kind of an idea of how much of a difference opening the window can make. Quite a bit. So a few thoughts and notes. I'm gonna give this a little bit of time to settle in and kind of figure out what the averages and the trends are. Now I ended up setting the range of mine, I believe it was to 1660, or yeah, let's double check. In here for the probe, and technically it should be, I know Thomas, I believe his was roughly around the same point where his worked out to get the right numbers. Yeah, so 1660, 0 to 1660. So if you guys do want to do it, you're probably going to be 1650, 1660. Again, take your voltage from a multimeter times by 400, and that's what the ppm reading should be on Apex, and you can just tweak that number until it matches up, and then you know you're in a pretty darn good place. Now, if you do want to build this, I will put links to the relevant stuff in the description, as always. The ASM module is a bit trickier to find. I have seen it online on some places, mainly in the UK. In US and Canada, aka North America, it tends to only come with the power monitoring kit. So if you have that, I mean, you already have one. If not, you might have to reach out to Neptune and order it directly. So it's a no. So a little more of an advanced project, but it's pretty cool. The other big thing to note is make sure that your CO2 meter is outputting 0 to 5 volts. Mine was supposed to do 0 to 5 or 0 to 10. Thomas has the same meter, his outputs 0 to 5. Harry's had the same meter, his does 0 to 5. Mine was not putting out 0 to 5. So I put 2 resistors in series, tapped off the middle to get my kind of half voltage divider for it. So that worked, it fixed it, but a couple extra steps that you normally shouldn't have to do. Now shout out to Harry, because as I was talking to him going through this process, he actually did a manual of this for Thomas, which basically walks you through what I built. So I will slap that in the description below because it'll make it easier for the next person that does it. So yeah, super cool way to pipe in the CO2 readings into the Apex. And yeah, I'm really curious to see how it correlates to pH over time and kind of figure out all those correlations. So yeah, I think it's going to be good. So if you guys learned something today, you geeked out with me, be sure to hit that like button. If you're new, you want to see more cool future projects, make sure you subscribe, and I'll catch you on the next update.